So now we'll be running through some scenarios and notes for the AWS Solutions Architect Associate exam. So if a company wants to review its security best practices after an incident where a new developer on the team was assigned full access to an Amazon DynamoDB table, and this developer accidentally deleted a couple of tables from the production environment, the most effective way to address this issue is to use permissions boundary to control the maximum permissions employees can grant to the IAM principles. And then if a company wants a low latency way to distribute live sports results using the UDP protocol, then the solution that offers the best performance for this use case is to use the AWS Global Accelerator to provide a low latency way to distribute live sports results. And then what if we have a situation where we have a big data analytics company that writes data and log files in Amazon S3 buckets, and then the company wants to stream the existing data files as well as any ongoing file updates from Amazon S3 to Amazon Kinesis data streams? Well, if you want the fastest possible way of building a solution for this requirement, then we can leverage the AWS Database Migration Service, AWS DMS, as a bridge between Amazon S3 and Amazon Kinesis data streams. And then if a company has set up AWS organizations to manage several departments running their AWS accounts and using resources, and they want to provide shared and centrally managed VPCs to all departments using the applications, then they should use VPC sharing to share one or more subnets with other AWS accounts belonging to the same parent organization from AWS organizations. And then if a team wants to migrate to a serverless architecture, one of the key points of consideration when using AWS Lambda as a backbone for this architecture is that they should know that since AWS Lambda functions can scale extremely quickly, it's a good idea to deploy an Amazon CloudWatch alarm that notifies your team when function metrics such as concurrent executions or invocations exceed the expected threshold. They should also know that by default, AWS Lambda functions always operate from an AWS-owned VPC and hence have access to any public internet address or public AWS APIs. And then once an AWS Lambda function is VPC enabled, it'll need a route through a NAT gateway and a public subnet to access public resources. And another thing you should know is that if you intend to reuse code in more than one AWS Lambda function, you should consider creating an AWS Lambda layer for the reusable code. And then if we have a scenario where most of the daily workflows would be centered around running batch jobs on Amazon EC2 instances with storage on EBS volumes, and they want to meet the HIPAA compliance norms for sensitive data stored on Amazon EBS, then we should know that the capabilities of an encrypted EBS volume is that data moving between the volume and the instance is encrypted, any snapshot created from the volume is encrypted, and data at rest inside the volume is also encrypted. And then if we have a company that's copied 1 petabyte of data from its on-premises data center to an Amazon S3 bucket in, let's say, US West 1, and they use an AWS Direct Connect link for this transfer, and the company now wants to set up a one-time copy of the data to another Amazon S3 bucket in, let's say, US East 1, so from one region to another. And let's say the on-premises data center doesn't allow for the use of AWS Snowball. So what they can do to accomplish this goal and transfer the data from one region to another is that they can set up an Amazon S3 batch replication to copy objects across Amazon S3 buckets in another region using the S3 console and then delete the replication configuration. And then they can also copy the data from the source bucket to the destination bucket using the AWS S3 sync command. Now let's say a company wants to use Amazon SQS to decouple components of the underlying application architecture, but the team is concerned about the VPC-bound components accessing Amazon SQS over the public internet. So in this case, we'd use a VPC endpoint to access Amazon SQS. Now let's say a company is provisioning a 2-tier application in a VPC with a public subnet and a private subnet. And let's say the team wants to use either a NAT instance or a NAT gateway in the public subnet to enable instances in the private subnet to initiate outbound IPv4 traffic to the internet. So in this case, we should know that a security group can be associated with a NAT instance, and a NAT instance can be used as a bastion server, and a NAT instance supports port forwarding. Now let's say a company has developed a REST API which is deployed in an auto-scaling group behind an application load balancer. And the REST API stores the user data in Amazon DynamoDB and any static content such as images in Amazon S3. And let's say they find that 90% of the read requests are for commonly accessed data across all users. While in this case, the most efficient solution to improve the application performance is to enable Amazon DynamoDB Accelerator DAX for Amazon DynamoDB and Amazon CloudFront for Amazon S3. And now let's say a company wants to stop owning and maintaining its own IT infrastructure. And now the company wants to archive about 5 petabytes of data in its on-premises data center to durable long-term storage. Well, the way in which they can migrate this data in the most cost-efficient, optimal way is to transfer the on-premises data into multiple AWS Snowball Edge storage optimized devices, and then copy the AWS Snowball Edge data into Amazon S3 and create a lifecycle policy to transition the data into Amazon S3 Glacier. And remember, we use a lifecycle policy because we can't transfer the data directly into Glacier. Now let's say a team has deployed a microservice to Amazon ECS. The application layer is in a Docker container that provides both static and dynamic content through an application load balancer. With increasing load, the Amazon ECS cluster is experiencing higher network usage, and it's found that 90% of this network usage is due to distributing static content of the application. And so to improve the application's network usage and decrease costs, you could distribute the static content through Amazon S3. And now let's say a company wants to roll out and test a blue-green deployment for its global application. And let's say most of the customers use mobile phones which are prone to DNS caching. So for them to test the deployment on as many users as possible in the given time frame, we could use AWS Global Accelerator to distribute a portion of traffic to a particular deployment. And now let's say a company has created an AWS Direct Connect connection for migrating its application to the AWS cloud. But before the migration cutover, the company must build a process that will replicate the newly created on-premises video files to the Amazon EFS file system, because the on-premises application writes hundreds of video files into a mounted NFS file system daily. And so the most operationally efficient way to meet this requirement is to configure an AWS data sync agent on the on-premises server that has access to the NFS file system, and then transfer the data over the AWS Direct Connect connection to an AWS Private Link Interface VPC endpoint for Amazon EFS by using a private VIF, and then set up an AWS data sync scheduled task to send the video files to the Amazon EFS file system every 24 hours. But now what if we have a situation where a team wants to manage a workload using a mix of on-demand and spot instances across multiple instance types, and they'd like to create an auto-scaling group with a mix of these instances? So the best option for the team to provision the instances for this use case is that they can only use a launch template to provision capacity across multiple instance types using both on-demand and spot instances to achieve the desired scale, performance, and cost. So they can't use a launch configuration, only a launch template to do this. And now let's say a company would like to use a network load balancer to handle millions of requests, and the team has provisioned multiple instances in a public subnet and specified these instance IDs as the targets for the NLB. But now the correct routing mechanisms for these target instances is that the traffic is routed to instances using the primary private IP address specified in the primary network interface for the instance. Now let's say a company stores its recreatable assets on Amazon S3 buckets, and the assets are accessed by a large number of users for the first few days, and then the frequency of access falls down drastically after a week. But even if it's not accessed that much after the first week, they must continue to be immediately accessible when required. And so a way to lower the storage costs while fulfilling the business requirements is that you could configure a lifecycle policy to transition the objects to the Amazon S3 one zone IA after 30 days. And you should know that the minimum storage duration is 30 days before you can transition objects, not 7 days. And then we should know when it comes to authentication or authorization mechanisms that AWS offers to authorize an API call within the Amazon API gateway, which also has built-in user management, is to use Amazon Cognito user pools. But then if a company wants to migrate from Amazon SQS standard queues to FIFO queues with batching, they'd have to follow the following steps in the migration checklist. Well, first they need to delete, not convert, but delete the existing standard queue and recreate it as a FIFO queue. They should make sure that the name of the FIFO queue ends with the .fifo suffix. They should also make sure that the throughput for the target FIFO queue doesn't exceed 3,000 messages per second. Now, let's say a company's cloud infrastructure is incurring a lot of costs for its business operations. And so a valid cost optimization solution is to use the AWS Cost Explorer resource optimization to get a report of the Amazon EC2 instances that are either idle or have low utilization, and use AWS Compute Optimizer to look at instance types and recommendations. Now let's say a firm uses a high-frequency trading system and wants to write log files into Amazon S3, and the system will also read these log files in parallel near real time. the team wants to address any data discrepancies that might arise when the trading system overrides an existing log file and then tries to read that specific log file. So the capabilities of Amazon S3 relevant to this scenario is that a process replaces an existing object and immediately tries to read it. And Amazon S3 will always return the latest version of the object. Now let's say a company is running a mission critical application using a single spread placement group of Amazon EC2 instances, and they need 15 Amazon EC2 instances for optimal performance. So how many availability zones will the company need? Well, in this case, just 3. Now, what if a company has an application that produces massive volumes of data that can be divided into hot data that needs to be processed and stored, and then cold data that needs to be kept for reference with quick access for reads and updates at low cost? So the best AWS service for this is Amazon FSx for Lustre. And now let's say a company is using Amazon Kinesis data streams to process IoT data from field devices, and they notice a performance lag for the data delivery speed between the producers and consumers of the data streams. So to improve this performance, you could use the enhanced fan-out feature of Amazon Kinesis data streams. Now, if a company wants to move any historical data into Amazon S3, but also wants to retain the ability to cross-reference this historical data along with the daily reports in Amazon Redshift, a solution with the least amount of effort and the minimum cost would be the following. Using Amazon Redshift Spectrum to create Amazon Redshift cluster tables pointing to the underlying historical data in Amazon S3. And then the analytics team can then query this historical data to cross-reference with the daily reports from Redshift and not AWS Glue. But now, what are some AWS services that can be used for buffering or throttling to handle traffic spikes? Well, you could use Amazon API Gateway, Amazon SQS Simple Queue Service, and Amazon Kinesis. Now, let's say a company's been running ad hoc queries on Oracle and PostgreSQL services on Amazon RDS, and they want to continuously replicate this data and consolidate these databases into a petabyte scale data warehouse by streaming the data to Amazon Redshift. So the most resource efficient solution that requires the least amount of development time without the need to manage the underlying infrastructure is to use the AWS Database Migration Service, AWS DMS, to replicate the data from the databases into Amazon Redshift. And now, what are some data sources that are supported by Amazon GuardDuty? Well, it supports VPC flow logs, DNS logs, and AWS CloudTrail events. Now, what if a company queries a data warehouse using a visualization tool, and the average size of a query returned by the data warehouse is 60 megabytes, and the query responses returned by the data warehouse aren't cached in the visualization tool, and each web page returned by the visualization tool is approximately 600 kilobytes. So the lowest data transfer egress, so going out cost for the company, is to deploy the visualization tool in the same AWS region as the data warehouse, and then access the visualization tool over a direct connect connection at a location in the same region. And now let's say an application is deployed on an Amazon EC2 instance. Because of an unknown bug, the application causes the instance to freeze regularly, and then the instance has to be manually restarted via the AWS Management Console. And so the most cost optimal and resource efficient way to implement an automated solution until a permanent fix is delivered by the development team is to set up an Amazon CloudWatch alarm to monitor the health status of the instance. And then in case of an instance health check failure, an EC2 reboot CloudWatch alarm action can be used to reboot the instance. Now let's say we have an application that requires up to 400 gigabytes of storage for temporary data that's discarded after the frames are rendered. And it requires around 40,000 random IOPS. And so the most cost-effective storage option for rendering this application is a storage-optimized Amazon EC2 instance with instance store storage. And then what command should a solutions architect run on the EC2 instance to gather system metadata? Well, they use the curl command with http 169.254.169.254 latest metadata. Now let's say an application runs on Amazon EC2 instances behind an ALB, and the instances run in an Amazon EC2 auto-scaling group across multiple AZs. And the application can take up to 15 minutes to respond to a request, and the solutions architect is concerned that users will receive HTTP 500x errors if a report request is in process during a scale-in event. So what they can do to ensure that user requests will be completed before instances are terminated is that they can increase the deregistration delay timeout for the target group of instances to greater than 900 seconds. Now let's say an application will consist of an application layer and an online transaction processing OLTP relational database. And the application will have unpredictable traffic patterns, and the company wants to pay the minimum for compute costs during these idle periods. And so the solution that will meet these requirements most cost effectively is to run the application in containers with the Amazon Elastic Container Service on AWS Fargate and use Amazon Aurora Serverless for the database. And now let's say a company uses one AWS account to run production workloads, and the company has a separate AWS account for its security team. And the security team needs to view specific account settings and resource configurations in the AWS account that runs production workloads. And now they need to provide the required access to the security team by designing a solution that follows the AWS security best practices. And so to do this, they can create an IAM role in the production account and then attach a permissions policy that provides the permissions required by the security team, and then add the security team account to the trust policy. And now let's say a company is deploying a new database on a new Amazon EC2 instance, and the workload requires a single Amazon EBS volume that can support up to 20,000 IOPS. And so the type of EBS volume that meets this requirement is the provisioned IOPS SSD. And now let's say a company is transitioning its Amazon EC2 based MariaDB database to Amazon RDS, and the database must provide at least 40 gigabytes of storage capacity and 1,000 IOPS. While the storage configuration for the Amazon RDS for MariaDB instance that's the most cost-effective is to provision 50 gigabytes of general-purpose SSD GP3 storage for the RDS instance. And now let's say an architect must configure security for a VPC to ensure that back-end Amazon RDS database instances can't be accessed from the internet. And they need to ensure that the database instances are accessible from the application tier over a specified port only. So the actions that a solutions architect can take to meet these requirements is to specify a database subnet group that contains only private subnets for the database instances, and then add an inbound rule to the database security group that allows requests from the security group of the application tier over the database port, and then remove other inbound rules. And then you should know a fundamental resource managed by AWS KMS is the Customer Master Key, CMK. And now let's say an application is extensively used during office hours from 9 a.m. in the morning to 5 in the afternoon. And the performance of the application is slow during the start of the day, but then works normally after a couple of hours. And so the best way to ensure the application works properly at the beginning of the day is to configure a scheduled scaling policy for the auto-scaling group to launch new instances before the start of the day. And so what we can do to ensure that our RDS database can only be accessed using the profile credentials specific to your EC2 instances via an authentication token, you could enable the IAM database authentication. And now let's say an IT manager is concerned about the over-provisioning of resources that can cause higher operating costs. And a cost-effective solution without affecting the performance of the application is to use a target tracking scaling dynamic scaling policy. And now let's say an online medical system hosted in AWS stores sensitive information in Amazon S3 buckets, and both the master keys and the unencrypted data should never be sent to AWS to comply with the strict compliance and regulatory requirements of the company. And so in this situation, we should use an S3 client-side encryption with a client-side master key. And to enable client-side encryption, you have the following options. You can either use an AWS KMS key or use a client-side master key. And then you should know that cross-origin resource sharing CORS defines a way for client web applications that are loaded in one domain to interact with resources in a different domain. And then you should know you can use the Redis auth command to improve data security by requiring the user to enter a password before they are granted permission to execute Redis commands on a password-protected Redis server. Now let's say EC2 instances are all launched in private subnets, and an internet-facing ALB has been provisioned and points to the existing EC2 instances as the target group. But then the team noticed that the internet traffic was not reaching the Amazon EC2 instances. While what they needed to do was to launch the public subnets in each availability zone and associate them with the application load balancer, and then modify the route tables for the public subnets with a route to the private subnets of the EC2 instances. And now let's say you want to monitor your EC2 instances based on a particular metric which is not readily available in Amazon CloudWatch. While the custom metrics that you can set up in CloudWatch, which are system level, are memory utilization, disk swap or space utilization, and not disk reads, page file utilization, and log collection. And now let's say a Lambda function is storing sensitive database and API credentials, and we want this information to be secure to prevent other developers in the team or anyone from seeing these credentials in plain text. While we could create a new KMS key and use it to enable encryption helpers that leverage on AWS Key Management Service to store and encrypt the sensitive information. Now let's say a company has a data lake solution in Amazon S3 to analyze large-scale datasets, and the solution makes infrequent SQL queries only, and the company wants to minimize infrastructure costs. Well, in this case, they can use Amazon Athena. You can run SQL queries directly against the data that's stored in Amazon S3 without provisioning any infrastructure. Now let's say we need a relational database with a multi-region disaster recovery RPO of 1 second and an RTO of 1 minute. Well, in this case, we can use the Amazon Aurora Global Database. Now let's say a company sees that the principle of least privilege is not being applied to the Amazon EC2 security group ingress and egress rules between application tiers. And so to correct this issue, they can create security group rules using the security group ID as the source or destination, and they can't specify an instance ID in the situation. Now let's say a company runs a site on premises and they have a product review that contained videos and pictures on the website, and the review went viral, and now they need to handle the spike in website traffic. Well, in this case, they can serve the images and videos using Amazon CloudFront distribution created using the news site as the origin. Now let's say an application allows users to create custom reports of historical weather data, and they generate a report that can take up to 5 minutes. And these are long-running requests, and they make the system unresponsive to other users. And so to make the system more responsive, they can use Amazon SQS with AWS Lambda to generate reports. Now let's say there's a situation where we have a single instance Amazon RDS MySQL database without encryption, but due to new compliance requirements, all existing and new data in this database must be encrypted. Well, they can take a snapshot of the RDS instance and then create an encrypted copy of the snapshot, and then restore the RDS instance from the encrypted snapshot. Now let's say an application stores documents on a shared NFS volume and references documents by using a multi-AZ deployment of an Amazon RDS for MySQL database instance. And let's say the document metadata is consulted regularly and the documents aren't accessed for more than one time a year, but they must remain immediately available. Well, in this case, they can use the Amazon S3 standard IA storage class for document storage, and then use an Amazon DynamoDB table to keep the document metadata. Now let's say a company has an application that detects when new objects are uploaded into Amazon S3 buckets. The uploads invoke an AWS Lambda function to write object metadata into an Amazon DynamoDB table and an Amazon RDS for PostgreSQL database. But to ensure high availability, you can enable multi-AZ on the RDS for PostgreSQL database. Now let's say a web application connects to a database running on a private VPC subnet, and the web servers must be accessible only to customers on an SSL connection. And the Amazon RDS for MySQL database server must be accessible only from the web servers. So the solution to meet the requirements without impacting the running applications is that you can open an HTTPS port on the security group for the web servers and set the source to all public traffic, so 0.0.0. And then open the MySQL port on the database security group and attach it to the MySQL instance, and then set the source to the web server security group. Now let's say a company is using AWS site-to-site VPN connections for secure connectivity to its AWS cloud resources from on-premises locations. But due to an increase in traffic across the VPN connections to the Amazon instances, users are experiencing slower VPN connectivity, and the internet connection used for the VPN has unused throughput. So the solution that'll improve the VPN throughput is using a transit gateway with equal cost multipath routing and add additional VPN tunnels. Now let's say the network between an on-premises data center and AWS will use an AWS Direct Connection, DX connection. And the application connectivity between AWS and the on-premises data center must be highly resilient. So to meet this requirement, we can configure direct connect connections at multiple DX locations. Now let's say a company has an application that tracks user clicks on its websites and performs analytics to provide near real-time recommendations. Now let's say the application has a group of instances that receive the data from the websites and send the data to an Amazon RDS database instance for long-term retention, and then has another group of EC2 instances that continuously check the changes in the database and run SQL queries to provide recommendations. But now the solution to meet these requirements and to provide the fastest access to the user activity is to use Amazon Kinesis data streams to capture the data from the websites, and Kinesis Data Analytics to query the data, and Kinesis Data Firehose to persist the data on Amazon S3. And so in this case, using Athena instead of Kinesis Data Analytics would have taken more time. Now let's say a company wants to create an audio version of its product manual, and the manual contains custom product names and abbreviations and is divided into sections. So in this case, they can use Amazon Poly and build custom lexicons for the product names and abbreviations and use the start speech synthesis task API operation for each section of the product manual. Now let's say a company performs batch processing on .csv files of sales data and stores the results in an Amazon S3 bucket once every hour. And the company runs one-time queries in Amazon Athena to determine which products are the most popular for a particular date, for a particular region, and the queries sometimes fail or take longer than expected to finish running. And so to improve the query performance and reliability, they can partition the data by date and region in Amazon S3 and then use an AWS glue extract, transform, and load process (ETL) process to convert the CSV files into a Posh Parquet format. Now let's say a company currently operates a web application backed by an Amazon RDS MySQL database, and a security audit requires future backups to be encrypted and the unencrypted backups to be destroyed. And so to set up an encryption for future backups, they should create a snapshot of the database, copy it to an encrypted snapshot, and then restore the database from the encrypted snapshot. Now let's say a database solution needs to support a high rate of random disk reads and writes, and it needs to provide consistent performance and requires long-term persistence. Well, in this case, the storage solution that they should use is an Amazon EBS provisioned IOPS volume. The provisioned IOPS volumes support a high rate of random disk reads and writes. The general purpose volumes aren't consistent. Now let's say a company wants to create an application that will transmit protected health information to thousands of service consumers in different AWS accounts. The application servers will sit in private VPC subnets, and the routing for the application must be fault tolerant. So in this case, you should create a VPC endpoint service and grant permissions to specific service consumers to create a connection. Now let's say an application runs on Amazon EC2 instances in multiple availability zones behind an ALB. The load balancers in public subnets and the EC2 instances are in private subnets and must not be accessible from the internet. And at the same time, the EC2 instances must call external services on the internet. And each availability zone must be able to call the external services. So in this case, they need to create a NAT gateway in each availability zone, and then update the route tables for each private subnet to direct internet-bound traffic to the NAT gateway, because NAT gateways can only be in one AZ, so they need to deploy them in each AZ. Now let's say a company wants to test software applications before sending traffic to them, and they want an efficient solution that limits the effects of application bugs. And so the combination of steps recommended is to apply Amazon Route 53 weighted routing to test the staging environment and gradually increase the traffic as the tests pass. And then use AWS CloudFormation with a parameter set to the staging value in a separate environment other than the production environment. Now let's say tasks run on an ECS cluster that uses Amazon EC2 instances across multiple availability zones. The amount of data that each task outputs is approximately 10 megabytes, and hundreds of tasks can run at the same time, and old outputs are archived and deleted, so the storage size won't exceed 1 terabyte. And so the storage solution that will meet the requirements with the highest throughput is an Amazon EFS file system with provisioned throughput mode. And now let's say a company is using Amazon DynamoDB with provisioned throughput for the inventory database tier of a website. And then during flash sales, customers experience periods of time when the database can't handle a high number of transactions taking place. But then during normal periods, the database performs appropriately. And so what they can do is switch DynamoDB to on-demand mode during flash sales. Now let's say a company uses Amazon CloudWatch metrics and alarms to monitor their architecture. And an architect notices that the company is not able to launch some instances. And they find the following message: EC2 quota exceeded. And so the way in which the architect can ensure that the company is able to launch all the EC2 instances correctly is that they can use service quotas to request an increase to the number of EC2 instances that the company can launch.